But when you're having hundreds of thousands of people dying in the country, and it's Operation Warp Speed to try to come out with something, just sort of like, okay, you pick a dose, you pick an interval, you get 2 groups, try it because you're trying to get the vaccine out to save lives.
Dr. Jonathan Bakhtari.
You can see it. I mean, it's crystal clear.
I think it's going to really revolutionize things.
Which is a big game changer.
Hi, welcome to another episode of Bakhtari MD. I'm Dr. Jonathan Bakhtari. And if this is your first time watching us, I am a pulmonary critical care expert. I'm also a vaccine expert, and I've been CEO of an adult vaccine company for more than a decade now. And what I want to talk to you today is I want to talk to you about Pfizer and Moderna, 2 leading mRNA vaccines, and some of the recent literature that's coming out talking about some of the potential differences between them. Some may be clinical, some may not, but we want to go over some of those recent studies and see what we can make out of it. And when it comes to understanding these kind of studies, I've been doing this for a long time, so hopefully you've come to the right place for someone not only to give you this data, but to digest it and give it back to you in a way that is meaningful and easy to understand. So the 3 studies I want to go over that involve the Pfizer and Moderna mRNA vaccines are really kind of bookends if you really put them together. And I want to go through each one individually and then talk about, what it means when you put these 3 studies together. So the first study I want to talk about is a study that was out of Belgium, and it was published in the American Medical Association very, very recently, last week or so. And what they did was very interesting. In Belgium, what they did is they studied the humoral response, meaning the antibody response of the Moderna vaccine, COVID-19 vaccine versus the Pfizer to see if given in the proper sequence that they're supposed to, meaning the Moderna 4 weeks apart, the Pfizer 3 weeks apart, what kind of antibody response would you get? And the antibody response that we're looking for is the antibody towards the spike protein of the coronavirus. Now, we all know prior to this study that both vaccines are 95% effective in certainly preventing death and hospitalization. But this study wasn't a clinical study. This was basically looking at what kind of antibody response you have. And that's really how vaccines work. When you get a vaccine, what's really doing is tricking your body into thinking it's seeing the whole virus by just giving a little bit of the virus. And in this case, the mRNA vaccines have a small genetic code that basically produces a small piece of the spike protein. Your body sees that, it thinks it's seeing the whole virus. I'll provide a link above to my talk on how mRNA vaccines work if you want to check that out. But if you already know that, we can move on. In this study, what they did is looked at the antibody level response after the second dose of each vaccine for those who had previously been infected and uninfected, meaning had gotten COVID or not gotten COVID prior to getting the vaccines, plus different age groups. The other important thing to understand is this was a group of healthcare workers. It wasn't the general population. You can read what you want into that. Higher antibody levels were observed in participants vaccinated with 2 doses of Moderna versus Pfizer, 3836 versus 1444. So at least a 2-to-1 increase in the amount of antibody response from the Moderna versus the Pfizer, at least in this study. As a whole, previously infected people had higher antibody levels to both mRNA vaccines, which kind of makes sense because they already had some antibodies now, and they're going to get even more with the vaccines. But in both cases, whether they were previously infected or not, the Moderna had higher antibody levels. So just to summarize, even with the uninfected, previously uninfected, or previously infected, the Moderna had higher levels of antibodies. The other interesting thing is they broke up this study into age groups less than 35, 35 to 55, and greater than 55. And again, with all age groups, you see Moderna with higher antibody levels. What's interesting, though, there's a negative correlation between age and antibody levels to both vaccines. So the older you are, the less robust the immune response was in terms as measured by antibody levels. So what does this study mean? Well, at least, the limitations of this study is obviously it was limited to a group of healthcare workers, and it didn't really correlate whether you had higher antibodies, whether you were less likely to get breakthrough infection. So we don't know that from this study. All we know is that you have a higher antibody level. And to the extent that that has a clinical meaning is unclear. And I think this is sort of where the study stops and lets potentially other studies answer the question of, one, if this is reproducible, the amount of antibodies that are produced. But one thing we can say is that when we look at Moderna and Pfizer, there may be a couple of explanations for at least why there is this higher antibody response. Number one, Moderna is given 4 weeks after the initial dose versus Pfizer is given 3 weeks after the initial dose. What does that mean? Well, you have to understand the second dose always is basically the dose that's going to respond to the system getting primed by the first dose. And so the theory would go, if you give your system longer to get primed, in other words, be ready for that second dose, the more robust you have. And that's one of the reasons we space out vaccines. Like even if you're going to get your measles, mumps, and rubella vaccine, you don't get, 3 1 day apart, or you don't get hepatitis B 2 days apart. Or you don't get hepatitis A. In fact, hepatitis A is 6 months apart. So different vaccines need a certain time to think of it as almost your system to percolate with the first one, get your bone marrow ready and recognizing. And the way I would sort of describe it is think of like the first dose as setting up the factory to produce cars or automobile. The first dose, they hire the workers, they get the plant, they train the workers and they get them ready to go. Okay. And yes, they may make a couple of cars, but really the first dose is to prime the system, meaning have your bone marrow, your B cells be set up the manufacturing process to create this new antibody that your body's never created before. So the first dose is the primer. And then you get a second dose, which then hits you, and then you get a big antibody response. So in this case, the argument could be made that with the Moderna vaccine, you have an extra week to get your factory in order and hire more employees. Okay. And then you get the second dose. And of course, what's going to happen? And the question people ask is, why did Pfizer or why did Moderna pick 4 weeks versus 3 weeks? Well, when a new vaccine is coming out, they don't know the optimal schedule. And during the middle of a pandemic, they really couldn't break it up into multiple arms. Normally, what I would have imagined would have happened is they would have taken different doses of the vaccine, different amounts of the vaccine, in different schedules, taken 2, 3, 4, 5 years to come out with the perfect schedule based on breaking the groups out into, you get a quarter dose, you get a half dose, you get a full dose, and this group gets double the dose. And within those group, one gets the booster after 3 weeks, a portion of that group gets it after 6 weeks, and a portion of that gets it after 8 weeks. And then after 3, 4 years of doing all that, we will come up with the optimal schedule. But when you're having hundreds of thousands of people dying in the country, and it's Operation Warp Speed to try to come out with something, just sort of like, you pick a dose, you pick an interval, you get 2 groups, try it because you're trying to get the vaccine out to save lives. So then the other differences between the vaccine is the actual amount of mRNA. So Moderna has 100 micrograms per a certain unit, and Pfizer has 30 micrograms. So almost 3 times as much more mRNA in Moderna. So on one hand, people go say, well, obviously Moderna is better because they just put more of the drug. But it's not clear to me necessarily. Now, it may be true, but it's not clear if you take 2 Tylenols that if you take 4 Tylenols at once, it's better per se. So more is not always better. But having said that, again, during a pandemic, when you're trying to come up with a dosage, you have to balance getting a robust response and having the vaccine work versus having side effects. So if you come out with a high enough dose that it really works really well, but 30% of people can't tolerate it, you really don't have a win. So when you're picking the dose, you want to, in an ideal world, in a utopian world, you want the least amount that will be effective to get the job done. So arbitrarily, if Moderna picked 100 and Pfizer picked 30, it's theoretically possible Pfizer may have been the better choice theoretically, in the sense that if they got the job done as well as Moderna with, let's say, 90% less side effects, they would have been declared the winner, right? Because so it's easy just to say, well, Moderna has 3 times as much. Well, of course, Moderna is the better vaccine. Not necessarily, because if you can get the same job done with less, now, or it may be sometimes that, yeah, you actually didn't put enough of a dose that to really have it be more protective or last longer potentially, you should have had a higher dose. So again, these are the shortcomings of trying to, I don't want to say rush a vaccine, but to bring a vaccine out, which is effective. But, the idea is let's get something out that will save lives, and we'll have the whole next decade or the next few years to fine tune the dosage, the intervals, how many doses should be in the series, how far apart. I mean, it may be in 5 years, 3 years, we may find out 3 or 4 weeks is not the right interval. Maybe 6 weeks is the right interval between first and second dose. Maybe 8 weeks is the right interval between first and second dose. But, trying to squash a pandemic, you lose some of that flexibility. So I want to leave that study with just saying, so we know from at least this study that Moderna provides a more of an antibody response. The question really is, does that translate into anything, practically speaking? Okay, so the next thing I want to talk about is a study published by the Mayo Clinic. Is titled Comparison of 2 Highly Effective mRNA Vaccines for COVID-19 During Periods of Alpha and Delta Variant Prevalence. Okay, so basically in this study, what they report is looking at the effectiveness at Moderna and Pfizer to either prevent infection or hospitalization from January to July, when the Alpha variant was initially the much more dominant one. So essentially, during this period, the Alpha variant was more prevalent. And of course, starting in July, you're starting to see more of the Delta. So more of this has to do with the Alpha variant. And the study reports that the Moderna mRNA vaccine was 86% effective at preventing infection versus Pfizer at 76%. And when it came to hospitalization, even better. The Moderna vaccine was 92% effective versus the Pfizer 85% effective. So, those are really good numbers, considering like the flu shot is, anywhere from 20 to 60% effective. So these are spectacular numbers that we live with from January, let's say June. But then they reported their numbers in July, when the Delta variant was clearly more prevalent. And what they found was a little bit shocking, that Moderna, for infection only, Moderna was 76% effective in preventing infection. So it went from 86 to 76. But Pfizer went from 76% to 42% effective in preventing infection. And let's go to hospitalization. Moderna went from 92% effective in preventing the hospitalization to 81% in preventing hospitalization. And Pfizer went from 85% in preventing hospitalization to 75%. So in their study, they basically report that Moderna had a 2-fold reduction in breakthrough cases, which is dramatic. How do we explain this? Obviously, this is a very select group. Also, it's unclear when these people actually got their vaccines. Was it 6 months after their second dose, 4 months after their second dose? But overall, it does say something about potential effectiveness of both when it comes to the Delta variant, but much more so the Pfizer vaccine. The one thing I do want to say, though, because on this study we talked about its effectiveness in preventing infection and hospitalization, but the one really good news is that they were both very, very, very protective against severe infection and death. So that is the good news. But in terms of preventing just infection, there may be an area of concern. So let me just say this. So this study does point out limitations of their study, that it was, mainly done in Florida and not geographically representative of the whole population. And there may have been other potential variations in terms of how they measured things, but those theoretically need to be confirmed in larger studies with a more diverse population. So the next study I want to talk about is a study published by Morbidity and Mortality Weekly Report, September 10th, 2001. It's called Interim Estimates of COVID-19 Vaccine Effectiveness Against COVID-19 Associated Emergency Room, Department, or Urgent Care Clinic Encounters or Hospitalization among adults during the Delta variant prominence in 9 states from June to August. Okay? So in this group, they looked at people who came to the ER, urgent care, or were hospitalized. They looked at vaccinated and unvaccinated people that had COVID. The people who were vaccinated, roughly about 55% or so, had Pfizer, about 36 to 38% had Moderna, and 6 to 10% had Johnson & Johnson. And they were about 110 to 93 days roughly as a median getting their 2 doses. So in this study, what they found in taking all comers having these vaccines, that roughly there was an 82% effectiveness in preventing emergency room or urgent care visits and an 86% effectiveness in preventing hospitalization. The Moderna vaccine had better numbers than the group. The Moderna vaccine had a 92% effectiveness in reducing emergency room visits or urgent care visits, and 95% effectiveness in preventing hospitalization. The Pfizer vaccine was less. The Pfizer vaccine, in terms of preventing emergency room visit or urgent care, was 77% effective versus 92% for Moderna, and was 80% effective in preventing hospitalization versus 86% versus Moderna. The J&J, of course, was 65% effective in preventing emergency visits and urgent care, and hospitalizations were about 60% for J&J. The other thing this study pointed out, while all three as a group were 86% effective in preventing hospitalization and 82% effective in preventing ER or urgent care visits, during this period where the Delta variant was more prominent, the vaccine effectiveness for hospitalization among 75-year-olds was significantly less than people less than 75. And I think that's the first time that's been reported. What makes this study interesting is this is the first time with the Delta variant that we are seeing a slight difference in the vaccine effectiveness between Moderna and Pfizer as measured by emergency room, urgent care visits, and hospitalization. The limitations for this study, while we have a median idea of when the vaccines were given, they weren't correlated per patient, so we don't really we don't have a good understanding if when they got their 2 doses impacted these results. And also, this was a study in 9 states and obviously didn't represent the whole United States population. So those were the limitations that they discussed. So what does all this mean? Obviously, there's some data here that says with the Delta variant, either when you're looking at antibody levels or a reduction in vaccine effectiveness for Pfizer, the data is pointing out that there may be some differences between these 2 vaccines. Some of it, again, has to do with the amount of mRNA in the Moderna vaccine versus the Pfizer. Some of it may have to do with the fact that Pfizer is given 3 weeks apart versus 4 weeks apart. And, whether that in the real world has translated to some of these changes, it's possible. But clearly with the Delta variant, we're starting to see differences in the effectiveness of both vaccines, and we are seeing potentially some differences between the 2 vaccines. Now, both Pfizer and Moderna have stated that after 6 months, they see a waning of antibodies no matter how high it is. So the question really becomes whether one wanes a little faster or not. I don't know yet, but the point is what this is all really pointing to is that both for Pfizer and Moderna, we may slowly have to go more towards a model which, for example, Israel's doing, which is looking at giving a booster shot to increase those antibody levels. Remember, there's more to protection than antibodies levels, although it may be very important. There's also what's called cellular immunity or T-cell immunity. So there's other things that may protect you after a vaccine besides the antibody response. But the antibody response, there are some studies show that the level of antibodies is a very good indicator of protection too. Having said that, I think we are definitely heading towards the booster world for both of these vaccines. And I think there is a world of study that needs to be done to really look at these vaccines in terms of, how many should be in a series, how far apart should they be spread, what is the optimal dose for the vaccine and or the booster. I know Moderna is thinking about cutting back their booster to half instead of 100 to 50 units per dose because they feel that the 100 may not be needed. I know the FDA is giving them some pushback, but these are the struggles in trying to come up with the right dose and the right interval and the number of shots in a series to get lifelong immunity. Because the goal of all this, assuming the variants stay relatively under control, is how many doses are we going to need to get lifelong immunity, or are the variants keep going to be changing that it's going to become a vaccine that we're going to routinely get throughout the years? So that's the unfolding story. But as you're seeing this data emerge, first of all, the antibody level is different between the two vaccines, and they have a different scheduling and different amount in each dose. That tells you we haven't found the perfect cocktail yet, although they're both 100, almost 95, 100% effective in preventing death. But in terms of preventing breakthrough infections and maybe even hospitalization, we're going to have to fine tune that. We're going to have to fine tune that with those things that I just mentioned. We're going to have to find the right doses. We're going to have to find the right number of shots. Okay, and then we're going to have to find the right interval. And if all that doesn't work, we have to then come up with new versions, maybe seasonally or every once in a while, to address that. So that's what the future looks like given all of this data. So let's just take a more satellite view on this. Despite all of this data, we know that all three vaccines are pretty good at preventing death. And if that's the marker that we're looking for, the recommendation is still to get the first vaccines, COVID-19 vaccine someone offers you, because at the end of the day, that's really preventing severe hospitalization and death is what we're interested in. And I think as time rolls by, my sense is more boosters will be offered to people. It's recommended you get the same booster as the original vaccine, just so it doesn't get complicated. And then more and more research will come out, and I will bring more of that research to you as it comes out and how it impacts you, so you can make the right decisions. Thank you for watching. Make sure you comment, like, and subscribe. If you have any questions or topics you want me to cover, please leave them in the comments below. Also, check out my website, Bakhtari MD, where you can sign up for my newsletter and for more information on healthcare. Thank you so much, and be well.